Hello, we're doing the second semester review. Here's the first page. In the first question it asks, which of the following shows a triangle and its reflection over the x-axis? Since this is the x-axis and this point and this point are the same distance from each other as is that and that, and that and that, we would have to say A is the only one that is the reflection over the x-axis. For question 2, an isometry is a transformation which does not have to preserve its position.
The camera in the room will be different from the one we have now.
The isometry will preserve angles, distances, and betweenness, but it does not change it does change the position. Number 3. If we're going to graph a triangle whose vertices are here, let me graph those 3 points. Here's 0, 5. And negative 7, 2. 1, 2, 3, 4, 5, 6, 7, 2. And negative 6, 7. 1, 2, 3, 4, 5, 6, 7. And we're going to reflect that over the line. X equals negative 3. There's the line x equals 3. To find the answers, we're going to have to reflect each of these points over the axis of symmetry here. And this point 0, 5, if I distance 3 from the line, so if I go distance 3 over, I get the point negative 6, 5. If I reflect the point negative 7, 2, I am distant 1, 2, 3, 4. If I go 4 this way, I get the point 1, 2. And if I reflect the point negative 6, 7, since it's a distance 3 from it, another distance for 3 would put that at 0, 7. For question number 4, if we're going to draw in the lines of symmetry in the equiangular hexagon at the right, because it's equiangular and not regular, we know that these 2 lines that I've highlighted in purple are longer than the others. It is not regular. If it were a regular hexagon, there would be 6 lines of symmetry. This line, this equiangular one, would only have 2 lines of symmetry going like that. Number 5, if we draw the lines of symmetry of the square, because it's a square, it's regular, and it will have as many lines of symmetry as there are points. So there's 2 that are that way and 2 diagonally. Question number 6. If we graph the figure and we want to rotate it, if I have the points negative 3, negative 2, and negative 6, 1, and negative 2, negative 5, and negative 7, negative 6. 1, 2, 3, 4, 5, 6. If those are my figures and I want to rotate those 180 degrees about the origin, well, when we rotate 180 degrees, we get a mapping of xy onto negative x, negative y. So my points would end up being 3, 2, 6, negative 1, 2, 5, positive 5, and 7, 6. If I was to graph those points, I would get the points 3, 2, 3, 4, 5, 6, negative 1, 2, 5, and 7, 6. And you get the same figure rotated 180 degrees.